All right, so we have a set of equations which are supposed to be balanced. The first few equations we can balance them without much of a trouble. Let's starting on with the first one. Now this is already balanced: calcium, 2 hydrogen on the left side, and calcium and 2 hydrogen on the right side. Already done and dusted. And if you take this one, you can see. Okay, on the left hand side we have 4 hydrogen but just 1 oxygen. On the right hand side we have 2 oxygen and 4 hydrogen. So oxygen is not balanced, and on the left hand side, sorry, on the right hand side, oxygen is going to be definitely in even numbers because it is OH2. Therefore, I think if you put a 2 here uh, and a 2 here, it will be balanced. Hope that is clear. This is in fact, yeah. Okay, that's how you balance it. Is easy. I hope you understood it. If you put a 2 here and 2 there, I think the reaction is balanced. Now see, if you see on the left hand side, you have 6 hydrogen atoms on the left hand side. On the right hand side also you have 6, and on the left hand side you have 2 oxygen atoms. On the right hand side you have 2 oxygen atoms, 1 calcium, 1 calcium. It's balanced. And here it's very easy. 3 magnesium on the right side, so you put a 3 magnesium on the left side. It's balanced already. And in this one, interesting, magnesium nitride reacting with water, we are getting magnesium hydroxide and ammonia. 3 magnesium on the left side. Here we should put 3. And how about balancing nitrogen? We have 2 here, therefore I have to put a 2 here. And ultimately, if you check carefully, we have 12 hydrogen on the right side, therefore I have to put 6 water molecules on the left side. Oxygen will be automatically balanced. We have 6 on both right side and left side. And if you take this reaction, it is in fact a disproportionation reaction where nitrogen here is +3 and nitrogen here is +3, and here nitrogen is +5, and here nitrogen is +2. So we have to balance the disproportionation reactions from the right hand side. That way it's easier to balance. Now if you start here, the difference between these two, the oxidation numbers will be, is 2 actually. It's 2. 3 and 5 difference is 2. That 2 goes here. Between these two, the difference is 1. That 1 goes here. We don't normally put 1 there. And now let's count nitrogen. We have 1 here and 2 here, altogether 3 here. If I put 3 here, will I be able to balance it? If I put a 3 here, is it already balanced? Yes, it's already balanced. If I put a 3 here, there are 3 hydrogen atoms. We have 1, here we have 2, done. 3 nitrogen atoms, here we have 1, here we have 2, balanced. We have 6 oxygen atoms on the left hand side. Here we have 3 plus 2 plus 1, balanced. And HNO3, here it is, here it's not disproportionation reaction. Here nitrogen go from +5, it has gone to +4. Oxygen from -2 has gone to 0. Right. I think we have to balance it normally here because there aren't 2 reactants here, just one thing undergoing decomposition. Right. So how do you balance this? What is the easiest method? I think we have to go for a 4 here and a 4 here and a 2 here. I think this would do. Because if I put a 2 here, then it's difficult to balance oxygen. Because once I put 2 here, we have 6, but we will already have more than 6 on the right side. Therefore, we have to go for a 4 here. And you can see 4 hydrogen on the right side, 4 nitrogen on the right side, and 12 oxygen on the left-hand side. And here we have 8, 10, 12. Done. And in this reaction, P4O10 is reacting with H2O, and you are getting this. 4 phosphorus, therefore, definitely I have to put a 4 here. And I have 12 hydrogen atoms, and here I have definitely put 6. And 16 oxygen on the left side and 16 oxygen on the right side. It's already balanced. Moving on to the next one, this is already balanced, very easy. And here you can see there are 2 chlorine atoms, So if I put a 2 here, hydrogen is also 2. I think it's balanced already. 8 oxygen on the left, 8 oxygen on the right. And then moving on to this one, SiCl4. 4 chlorine on the left, so I have to put a 4 here to balance the chlorine. And if you check hydrogen carefully, we have 6 on the right hand side. Therefore, I have to put 3 here, and you can see oxygen is automatically balanced 3 and 3. And if you come to this, 3 chlorine on the left side, and definitely I will have to put a 3 here to balance it off. And hydrogen, we have 6 on the right side. Therefore, I have to put a 3 to balance hydrogen. Oxygen will be automatically balanced. And if you take this reaction, I see 3 chlorine atoms on the left side. To balance that, I have to put a 3 here. Phosphorus is already balanced. And there are 6 hydrogen atoms on the right side. To balance that, I have to put 3 water molecules. Oxygen, 3, 3, balanced. And then go to the next one, PCl5 and water. 5 chlorine on the left side. To balance that, I will put a 5 here. And then hydrogen. I have 8 on the right hand side. Therefore, I have to put a 4 here. So that's it. And then the next 5, again, pretty much easy. This arsenic chloride reacting with water. 3 chlorine on the left side. So to balance that, we have to put a 3 here. And there are 6 hydrogen atoms. To balance that, we have to put a 3 here. That's it. It's pretty much it. Done. 3 oxygen on the left, 3 oxygen on the right. And in this one, if you see, look carefully, 1 Sb antimony and 1 antimony here, 1 oxygen here, 1 chlorine here. Here we have 3 chlorine. So if I put a 2 here, chlorine atoms will be balanced. 2 hydrogen here, 2 hydrogen, balanced. That's all. And if you come to this, tetraphosphorus decoxide. Okay, deca is the number we give for 10. That is reacting with sodium hydroxide. What is happening here? Now, there are 4 phosphorus atoms. 4 phosphorus atoms here. To balance phosphorus, I have to put a 4 here. And I have 12 sodium on the right side. Therefore, I have to put a 12 here. And totally, how many hydrogen atoms do I have? 12 on the left side. So I have to put 6 water molecules. To check whether you have done it correctly, you have to count oxygen atoms. On the left side, I have 10 plus 12, 22. On the right side, I have 16 plus 6, 22. And this one also should be pretty straightforward. If I put a 2, I think it's already balanced. Yeah, 2 nitrogen, 2 hydrogen, and oxygen. We have 5 on the left side. 4 plus 1, 5 on the right side. Pretty straightforward. Chlorine. This is dichlorine heptoxide. Dichlorine heptoxide reacting with sodium hydroxide. 2 chlorine atoms. Therefore, I have to put a 2 here. 2 sodium. I have to put a 2 here. And if you check carefully, we have 2 hydrogen on the left, 2 hydrogen on the right, 9 oxygen on the left, 7 plus 2, 8 plus 1, 9 on the right as well. So these pretty straightforward. You can directly balance them. Now here, you have to use the oxidation reduction method. Now what are we going to do? Let's see. Not that hard. A carbon from 0 has gone to plus 4. Whereas HNO3, nitrogen, from plus 5 has gone to plus 4. When a metal reacts with a conc HNO3, the metal nitrate will be produced. Then there is a certain amount of difficulty. But here, it's just a non-metal. HNO3 directly goes to NO2. So there won't be a big problem. Now, carbon from 0 goes to plus 4. What's the difference? 4. That 4 must be put in front of this. Nitrogen from 5 goes to plus 4. What's the difference? 1. That 1 should be in front of carbon. We don't put that normally. 4 hydrogen atoms. So therefore, we have to put a 2 here. 4 nitrogen atoms. We have to put a 4 here. Okay. Oxygen. Check. We have 12 on the left. 2 plus 8 plus 2. Again, 12. Done and dusted. Balanced. Fine. Next question. Sulfur 0 goes to plus 6. Nitrogen from plus 5 goes to plus 4. Sulfur from 0 to plus 6, difference is 6. That 6 comes here. Nitrogen from plus 5 to plus 4, difference is 1. That 1 comes here. 6 hydrogen. Careful now. 6 nitrogen. Let's balance 6 nitrogen first. I have to put a 6 here. Sulfur 1. So I leave this as 1. Don't put anything in front of this because I have only 1 sulfur on the left side. I should have 1 sulfur on the right side. Then check hydrogen. I have 6 on the left side. I have only 2 on the right side. Therefore, I have to put a 2 here. All right. And finally, what will you do? You will be checking the total number of oxygen atoms. 6 into 3, we have 18 on the left side. 4 plus 12 plus 2, 18 on the right side. Done. Copper oxide reacting with ammonia. Copper at plus 2 goes to 0. Nitrogen, which is at minus 3, goes to 0. Plus 2 to 0, the difference is 2. Minus 3 to 0, difference is 3. 3 copper, 3. 2 nitrogen, already balanced. 6 hydrogen and 3 oxygen. Therefore, we put a 3 here. Simple as that. Okay, right, straightforward. And then this one. Since you are in grade 12, they will provide you the entire equation, but in future, in future lessons, you will need to know in grade 13 and all, you will know how to write this entire equation on your own. right? So with practice, you will get it. Don't worry. Next one. Now, KMnO4, potassium permanganate, where manganese is in +7 oxidation state, reacting with H2SO4 in the present and H2S here. And then the reaction is happening this way. Now, one thing you have to understand is here the reacting species is H2S. From -2, sulfur will go to 0. Now, this might be a little challenging to you because we haven't done questions like this. H2SO4, it is providing the acidic medium. That's all. It is providing the acidic medium. So these sulfate ions on the right hand side came from this H2SO4. This I'll just underline them. This from this sulfate only, this sulfate and this sulfate were released. All right. So you will use H2SO4 in this question only to balance the sulfates. H2S is the one which turns to sulfur. You have to be absolutely sure about that. Okay, fine. Now, in KMnO4, manganese is +7. It goes to 8. Maybe perhaps I should use a different color for that for a better understanding. Right, I'll go for blue for MnO4. Right, this is from +7. It goes to +2. In MnSO4, manganese is +2. Sulfur from -2 goes to 0. -2 goes to 0. So for sulfur, the difference is from -2 to 0, 2. That 2 comes in front of this because that is the other species, that is the species which is undergoing reduction. This is the species which is undergoing oxidation. So you have to use this and this. This is the acidic medium. In the next reaction also same thing. Okay. And manganese from +7 to +2, difference is 5, and that 5 comes in front of H2S. All right, fine. So let's get going. With this 2 potassium already balanced, 2 manganese, you put a 2 here, and with this 5, careful, with this 5, you need to balance the sulfur, not sulfate, because H2S is the one which is becoming sulfur. So 5 sulfur, you have to put a 5 here. All right, fine. Right, then next we have to balance the sulfate ions. Now, how many sulfate ions do I have on the right side? 1, 2, 3. I have 3 sulfate ions on the right side. To balance that, I have to put a 3 here. Okay, what is this 3? To balance sulfate on right side. Right, and then what should I do? Finally, to seal it, I have to count the hydrogen atoms. Here I have 6, here I have 10. 6 plus 10, 16 hydrogen on the left side, and I have to put 8 here to balance it off. Then hydrogen is balanced. Now, to recheck, you count oxygen on either side and see. 8 oxygen here, 2 into 4 is 8. Here I have 12, 8 plus 12, 20 on the left side. Then go to right side. How many do we have? 4, 8, 12 to 20. But it's like this. Don't count sulfate because we have already counted balanced sulfate, 3 sulfate. 3 sulfate were already balanced. Just count the remaining oxygen. We have 8 oxygen here. We have 8 oxygen here. So it's automatically balanced. Right? I think that's the problem you might have encountered in this question. H2SO4 here, it is an acidic medium. In the next reaction is also, it's the same. Now, how do you start this? This is again a redox reaction. We are in dichromate. This is potassium dichromate. Chromium is at +6 oxidation state, and it goes to +3 because there we have chromium 3 plus here. It goes to +3. And we know this is the acidic medium. This gives us the acidic medium, H2SO4. So we don't use that as a oxidizing or reducing species. Then H2S, in H2S, we know sulfur from -2, it will go to 0. -2 goes to 0. Right. Then what do? Chromium from 6 to 3, difference is from 6 to 3, the difference is 3. But there are 2 chromium atoms. Therefore, I have to put a 6 here. sulfur from -2 to 0. So I have to put a 2 here. The difference. The difference, this is the oxidizing species which is undergoing oxidation. The difference should be given to the other species. But we have 2 is to 6, which is not the simplest ratio. So it's better if you can change it to the simplest ratio. 2 is to 6 is 1 is to 3. So let's change it to 1 is to 3. So 1 we don't put normally. I'll just put the 3 here. Hope you guys understood that. Right. And with that 3, let's balance this sulfur. So 3 comes here. I'll underline 3. That's because H2S is the one which turned to sulfur. So with this 3, you have to balance the sulfur. And chromium, we have 2 here, and we have 2 chromium already. It's already balanced. We have 2 chromium here. We have 2 chromium here. It's already balanced. We have 2 potassium on the left side. We have 2 potassium on the right side as well. It is also already balanced. So you should not disturb this or disturb this because they are already balanced. And then you have to count the sulfate ions. Now let's count the sulfate ions. I have 1 here. I have 3 here. I have 1 here. I have 3 here. So I have to put a 4 here. Okay, this 4 is also to balance the sulfate on the right side. I have 1, 3. Why didn't I put anything in front of this? Because the ratio was 1 is to 3. In front of that, there is 1. 2 potassium, we have 2 potassium here. 2 chromium, we have 2 chromium here. So it's already balanced. Fine. Moving on, it's balanced the rest. What should I do next? Yeah, hydrogen atoms. So how many hydrogen atoms do I have on the left-hand side? I have 8 here. I have another 6 here. 8 plus 6 is 14. To balance the 14 hydrogen atoms, I have to put 7 in front of water molecules. And this 7 oxygen will balance out this 7 oxygen. So 1, 4, 3, 1, 1, 3, 7. Those are the stoichiometric coefficients for this equation. Fine. If you focus on the next example, this one. In this one, iron, it's at +2 oxidation state, and here you know it has gone to +3 oxidation state. Manganese in this one, it is at +7 oxidation state, and manganese on the right-hand side is at +2 oxidation state. All the others, their oxidation number is not changing. Fine. So starting off with iron from +2 to +3, the difference is 1. So just vaguely put that 1 here. Manganese from +7 to +2, difference is 5, and that 5 comes here. But the problem is, here we have 5 iron, here we have 2 iron. On the right side, it's definitely going to be an even number. So you can't balance an even number with an odd number here. Therefore, this 5 and 2 must be changed to 10 and 2. That's the only way you can balance iron. Hope you all understood that, because we are getting 5 is to 1 like we usually get. But the problem is, with this 5, you can't balance this Fe2. You can balance it, but you will have to put a fraction, which is something we don't normally do. If you put 5 by 2, it will be balanced, but for the other parts, it will be complicated. Therefore, we always prefer to go for integers. So 10 and 2 should be the stoichiometric coefficients, right? With that 10 and 2, you have to balance the remaining ones. Now with this 10, I will underline that in blue color, 10. With this 10, what are the parts I can balance? So with this 10, I can balance this iron, which is 10 iron, 10 Fe ions are there. So here also, if you put 10, that means 5. 5 into 2 is 10. And that's all I can balance, iron. The cations should be balanced. And then with these two, we have to balance potassium and manganese. Now, potassium, it's already balanced. It's already balanced, K2. No problem. 2 manganese, so I have to put a 2 here. Done. All right, done. Fine. Potassium is balanced. Here it should be 1. It should be 1 here, but we don't put that 1. Right, fine. So 5, 1, 3, 5, 1, 2 fixed. This position fixed. These 2 fixed. So only 2 left are H2SO4 and H2O. Now let's count the sulfate ions. Now let's balance sulfate. Now how many sulfate do I have on the left side? I have 10. I'm trying to find out what number I should be using here, all right? And I'll just underline the sulfate here. on the left hand side, I have 5 into 3, and here one more, and here 2 more. Altogether, I have 18 sulfate ions on the left hand side. Hope this is clear. How 18? 5 into 3, 15, and here 1, 16, here 2, 18. Here I already have 10, so I need another 8. So I put a 8 here to balance the sulfate ions. Okay, here we have 18, here we have only 10 with this FeSO4, then I need another 8. And now I have to balance the hydrogen atoms. I have 8 H2, that means 16 hydrogen atoms. To balance that out, I have to put 8 H2. So the ratio will be, the stoichiometric coefficients will be 10, 2, 8, 5, 1, 2, and 8. Those will be the stoichiometric coefficients. Let's start with this equation, right? So in this one, you can see sulfur is from, it's at +4 and has gone to +6. In all these, you can see sulfur is +6. Here also it's +6, here also it's +6. So it has gone to +6. Therefore, the difference is from +4 to +6. In everything, it is +6. Therefore, you can take the difference as 2, and that 2 will go in front of potassium permanganate. In potassium permanganate, manganese is at +7 oxidation state, and here manganese is in +2 oxidation state. I'll get rid of this. +2 oxidation state. Right? What's the difference there? +7 to +2, the difference is 5, and that 5 goes in front of SO2. Okay, fine. So you have to carefully balance the reactions here. Now, with these two, if I balance potassium and manganese, potassium is already balanced. I have to put a 1 here, but we don't normally write that 1. I'll put a dot here. It's already balanced. 2 manganese, you put a 2 here. Okay, with this 2, I have done the balance. Right. And then we have to count how many sulfur altogether are there. If you take the left-hand side, we have 5 sulfur atoms. At the moment, 5 sulfur atoms. On the right-hand side, if you take, we have, now these two are already balanced. This is 1, this is 2, it's fixed. We can't change that. I have 1 and 2 here. Therefore, 3 sulfur atoms on the right side, but 5 on the left side. Therefore, I have to put a 2 here to balance it. And finally, 4 hydrogen atoms are there on the right side. To balance that, I have to put 2 water molecules. Fine. Now, let's recheck that with the number of oxygen atoms. I have 10 here, 8 here, 2 here, 20 oxygen atoms on the left hand side. On the right hand side, 4, 8, 8 plus 8, 16, and 4, 20. So you have that 20 and 20. Right. The stoichiometric coefficients will be 5, 2, 2, 1, 2, 2. 5, 2, 2, 1, 2, 2. And the next one, if you take this question now, let's start that. There again, it's the same, pretty same, sulfur +4 and chromium +6. Sulfur from +4 has gone to +6. You can see it's here also it's +6. Here also it is +6. So sulfur has gone to +6. Therefore, the difference is 2. I'll put that 2 here. Chromium from +6 has gone to, sorry, I forgot to write the oxidation number of chromium. It's from +6, it has gone to +3, the chromium atoms. +6 to +3, the difference is 3, but there are 2 chromium atoms, therefore you will put 6 here. Difference is 3, but 2 chromium atoms are involved, so you put 6 here. Fine. This is 6:2, and we don't need that to balance. It's not the simplest ratio, so it's better if you can simplify it. 6:2 can be changed to 6:2 can be changed to 3:1. Therefore, I'll leave it as 1 here, and I'll put a 3 here. All right, fine. Now let's start balancing. With this 3, I can balance. Yeah, with that 3, I don't think we can balance anything, so we'll let it be. Because yeah, sulfur is everywhere, so I'm gonna keep it on hold. 2 potassium. Now, with using this potassium dichromate, let's balance them. 2 potassium. Here we have 2 potassium, so this is settled. This is settled. We can't put anything here. 2 chromium. 2 chromium already balanced. This is also settled. So I'll put a dot here. You can't put any number here. Settled. Okay. Right. Now on the right hand side, if you check the number of sulfur, we have 1 here. We have 3 here. So altogether we have 4. 1, 3, 4. And on the left hand side, we have 3 and we have 1 here. So left side also we have 4. So it's already kind of balanced. All right, fine. And then you have to check the hydrogen atoms. On the left hand side we have 2, on the right hand side we have 2. So that's pretty much it. This is the reaction. It's just 3 1 1 1 1 1. Surprisingly, that's it. But to confirm whether our answer is correct or not, let's check the oxygen atoms. Here I have 6, here I have 7. 6 plus 7 is 13, 13 plus 4 is 17 oxygen atoms on the left hand side. Go to the right hand side now. I have 4 here, right? And I have 12 here. 4 into 3 is 12. 4, 12. And here I have 1. 4 plus 12 plus 1 is 17. 17 oxygen on the left, 17 oxygen on the right. That is it. So the ratio you should have got is, ratio in the sense the stoichiometric coefficients you should have got is 3, 1, 1, 1, 1, 1. All right, next one. This is a bit different than the other questions, so I'll use another color, maybe green. Let's go with green. Sulfur plus 4, and from plus 4 it will go to plus 6. There's no other place we have sulfur plus 6. Iron, in this one it's plus 3. It goes to plus 2. Plus 3 to plus 2. All right, let's start. Sulfur from plus 4 to plus 6, the difference is 2. That 2 comes in front of this. Iron from plus 3 to plus 2, difference is 1. That 1 comes here. We don't put that 1, correct? 2 iron, so I have to put a 2 here. 1 sulfur, it's already balanced. Right, and chlorine, how many do we have? We have HCl here, right? It's HCl. We have 6 chlorine, therefore I can put a 6 here. And how many hydrogen atoms should I put? I have wait, no. I have 6 chlorine here. Here we have 4 chlorine. Sorry. Here we have 4 chlorine. Therefore, I have to put a 2 here. Sorry, check it again. 6 chlorine on the left. I have 4 already on the right. So I just have to put a 2 here to balance it off. And then let's count hydrogen. I have 2 plus 2, 4 on the right. Therefore, I have just to put 2 here. Right. That's it. Look at oxygen. 2 plus 2, 4. And on the right side, we have 4. That's it. So it's 1, 2, 2, 1, 2, 2. All right, and let's move on to the next question. I think we missed this one. Let's focus on this. In this one, you can see sulfur. Here sulfur is at -2 and here sulfur is at +4. And this sulfur also has become 0 sulfur. This -2 has become 0. This +4 sulfur also has become 0 sulfur. See, this reaction is called a comproportion reaction. The opposite of disproportionation reaction, comproportion reaction. The name is not that important, but interesting fact is both are sulfur and both the sulfur atoms at different oxidation state become the same species. That's the interesting part. All right. So you can, if you see sulfur, this sulfur from -2 to 0, the difference is 2. You put that 2 here. You put that 2 here. And this sulfur from +4 to 0, the difference is 4. But what's the problem? 4:2 is not the simplest of form. So we have to simplify it to 2:1. 2:1. Already done. Right. I have 4 hydrogen atom on the left hand side. So I'll put a 2 here to balance it off. And I have, look, oxygen is already balanced. 2 oxygen here, 2 oxygen balanced. And sulfur, you have to carefully balance it. I have 3 on the left hand side. So I have to put a 3 here to balance it off. So the ratio, the stoichiometric coefficients will be 2, 1, 3, 2. 2, 1, 3, 2. And then moving on, this is very straightforward. This is very, very straightforward. I think you just have to put a 2 here. It will be balanced. A metal reacting with a diluted acid, it's very straightforward. You just put a 2 here, it's done and dusted. Now here you have to be a little careful. This one, right? Because in this one, the acid is undergoing reduction. And also it is providing the nitrate ions for the metal cation. Now magnesium, if you look closely, initially it's at 0. In magnesium nitrate, it is +2. So what we have here is magnesium 2+. So nitrate ions are provided by the concentrated acid. And also if you look at the oxidation number of the concentrated acid, from +5, it has gone to +4. So concentrated ion undergoes reduction as well. So it is doing 2 things. It's undergoing reduction and it's providing nitrate ions to the metallic cation as well. Fine. Now, let's first of all focus on the oxidation numbers. Now, from 0 to 2, we'll get a 2 here, difference. And from 5 to 4, difference is 1. That 1 comes here. So, we don't put that 1, but anyways, you know, there's a 1 here. With this 2, you have to balance this nitrogen. You put a 2 here. All right, I'll just underline that nitrogen like this. With this 2, you balance this nitrogen, because that we are balancing the nitrogen with underwent reduction. But now if you check nitrogen atoms on left and right side again, on the right side we have 2 and 2, 4. On the left side we have only 2. So you have to change this to 4. This is a special case where you have to put a number, check it, and then rechange it. This is one of a kind, a different approach. All right, done. So I think that's okay. Initially, I put 2 there. With that 2, I balance this, and then I can I check the number of nitrogen atoms on the right side again. It was 4, so I have to cancel it out and put 4 here, right? And then I have to balance hydrogen. Careful, 4 hydrogen on the left hand side. Therefore, I will put a 2 here. Okay, right. Now I'm not going to waste my time to balance not the next one, the other one, because instead of magnesium, we have copper. Instead of magnesium here, we have copper. The rest is pretty much the same. The rest is pretty much the same. So here it will be 1 copper, 4 HNO3, 2 NO2, 2 water. It's going to be the same, pretty much the same. Just they have changed magnesium and copper. That's all, right? Fine. But the next reaction is a little different. You have to be careful, because copper from 0 goes to +2. Nitrogen in HNO3 from +5 goes to +2. So there you have to be a little careful. Copper from 0 to 2, that difference is 2. Nitrogen from +5 to 2, difference is 3. All right. Now 3 copper, with that 3, I'll underline, put a double line here. I have to put a 3 here to balance copper. With this 2, I have to put a 2 here to balance this nitrogen which underwent reduction. But if you recheck it, now recheck the number of nitrogen on the right side, 2 here, and here we have 2 into 3, 6. 6 and 2. 6 plus 2. I have 8 here, but I have only put a 2 here. Then what should I do? I should cancel this 2 and put an 8 here. Okay, again, I repeat, this is a exceptional case where you have to do it trial and error method. 8 comes here. And I have 8 hydrogen on the left hand side. To balance those 8 hydrogens, I have put 4 water molecules. If you want to be absolutely sure whether you have done it correctly, you can always check the number of oxygen atoms on either side. We have 8 into 3, 24 oxygen atoms on the left hand side. And on the right hand side, 3 into 2 is 6, into 3 is 18. 18 into 2, 18 plus 2 is 20, 20 plus 4 is 24. On the left, I have 24. On the right also, I have 24. All right. So these two are, somewhat special. You have to put a number, recheck, and you have to rechange the number. That's how you do it. All right. So let's get started with the other equations, and starting off with this. Chromium +6. And H2S is at -2. These are ionic equation where we have to balance using the ions, right? Right, ionic equations. Chromium +6 here, higher sulfur -2. Chromium from +6 goes to +3. Sulfur from -2 goes to 0. So difference for chromium is 6 and 3. 6 from 6 it goes to 3, but there are 2 chromium atoms, so I have to put a 6 here. And sulfur from -2 to 0, difference is 2, but it should be 1:3 because we have to go for the simplest ratio. So I'll change it to 1:3. 2 chromium here, I have to put a 2 here. 3 sulfur here, therefore I have to put a 3 here. Right? Okay, this is locked, this is locked, this is locked, this is locked. Right, fine. Then next, I have to balance oxygen. That's the easiest method. I have 7 oxygen on the left-hand side. Oh, I have to put a 7 here. And then I have to balance hydrogen. I have 14 hydrogen on the right side. And here I have only 6, therefore I have to put 8H plus here. 8H plus here. And that way reaction will be balanced. Fine. And next one, chromium +6, sulfur +4. Chromium +3, sulfur plus 6. Chromium from plus 6 to plus 3 difference is 3, but there are 2 chromium atoms, so I have to put a 6 here. Sulfur from plus 4 to plus 2 difference is 2. I have to put a 2 here, but again, it's not the simplest ratio. So 2:6 must be made 1:3. Done. 2 chromium atoms, let's put a 2 here. 3 sulfur atoms, let's put a 3 here. All right. Then what should I do? Yeah, just like before, we can try to balance the oxygen atoms. I have oh god, no, I have I have 13 oxygen atoms on the left hand side. You can see 7 plus 6, 13 on the left side. And how many do I have on the right side? 12 and 1, 13. It's already balanced. And I have 2 hydrogen atoms here, so I have to put 2H plus so that it will be balanced. Done and dusted. Next one, chromium plus 6, iron plus 2. From plus 6, chromium goes to plus 3. Iron from plus 2 goes to plus 3. When you take chromium plus 6 to plus 3 difference is 3. There are 2 chromium atoms. Therefore, I have to put a 6 here. Iron from plus 2 to plus 3 difference is just 1. So, I have to put a 1 here. All right. So, 6 is settled. That this 1 is settled. 2 chromium. Therefore, I have to put a 2 here. It's settled. 6 Fe2 plus. So, I have to put a 6 here. Settled. And next, let's balance oxygen. Right. I have 7 oxygen on the left hand side. So if I put 7 water, oxygen will be balanced. And I have to check the hydrogen atoms. I have 14 hydrogen on the right side and no other hydrogen here. So only in this one, I have to put a 14. Right. Now it's balanced. Right. Okay. And yes, that's it. Hope you understood that. Done. And in this one, now this one, I think you have to be a little careful in this one. You have to be a little careful here. Chromium plus 6. All right. Chromium is plus 6. If you look about, if you consider HCl, yeah, it is at -1. But the problem is this HCl is doing 2 things. It is turning to Cl2 and it is providing Cl minus ions also. You have to be a little careful there. This turning to Cl2 and providing Cl minus ions as well. All right. So let's start the difference now. Chlorine here is 0 and chromium is plus 3. Right. Chromium from plus 6 to plus 3 difference is 3, but there are 2 chromium atoms here. Therefore, I should put a 6 here. Chlorine from -1 to 0 difference is 1. So I should put a 1 here. This part is settled. Now I'll put a dot, means it's settled. Right. This is not settled. Wait. Now 2 chromium are there, so I have to put a 2 here, settle it. And with this 6, I should balance this chlorine and I should put a 3 here. Because HCl is doing 2 things. One, it is turning to Cl2, and the other one, it is providing the Cl minus ions, the excess ones. Right? Fine. And what else should we do? We need to balance the oxygen atoms. The only way to balance oxygen atoms is here we have 7. Here we have 7. So I have to put 7 here. Right. Okay. Now look at hydrogen. Look at hydrogen, people. Look at hydrogen. Here I had to put 7 in front of oxygen because then only that's the only way to balance oxygen. But if you check hydrogen now, I have 14 on the right side. I have 14 on the right side, but I have only 6 on the left side. Therefore, the 6 must be cancelled out. And I have to put a 14. I have changed it to 14. That's why I did not fix it. Because HCl is doing 2 things here. It's undergoing oxidation as well as providing Cl minus ions. And then check chlorine ions. 14 on the left side. I have only 6 on the right side. All right. Therefore, I have to put 8 here. Remaining will be Cl minus. Remaining will be Cl minus. Yeah. So this is the way you have to balance this reaction. It's another exceptional case where you have to put a number, recheck that, cancel it out, and put a new number. Next one. Now, in the next example, H2O2 is involved. Whenever H2O2 is involved, this is how you have to handle that question. Right, let's start. MnO4 minus, it is plus 7. And here, manganese is plus 2. In H2O2, oxygen is -1 and in O2 oxygen is 0. So oxygen is getting oxidized, manganese is getting reduced. +7 to +2, difference is 5. Oxygen from -1 to 0, difference is 1, but there are 2 oxygen atoms, so you have to put 2 here. So let's settle this and this. 2 manganese, therefore I have to put a 2 here, settle it. And careful, this H2O2 is the one which becomes oxygen. This H2O2 is the one which becomes oxygen. So with this 5, we have to balance the oxygen atom. So how many oxygen atoms do I have in H2O2? 10. So you have to put a 5 here. All right, good. And then what else can we do? We have to balance the remaining oxygen atoms. Here we have 8. Hope you can see. This 10 is already balanced. This 8 must be balanced out by water. So I have to put 8. Then only water will be balanced. And then carefully count hydrogen atoms. On the right side, on the left side, sorry, I already have 10. On the right side, I have 16 hydrogen atoms. 10 hydrogen atoms on the left side, right I have 16, therefore I need to put a 6 here to balance hydrogen atoms. So 2, 5, 6, 2, 5, 8, 2, 5, 6, 2, 5, 8. That will be the answer. This is also a little similar to that, because here we have +7. Is it a little similar to that? No, not really. Okay, +7, and here sulfur is -2. From manganese from +7 goes to +2, sulfur from -2 goes to 0. So +7 to +2, the difference is 5. -2 to 0, the difference is 2. 2 manganese, I have to put a 2 here. 5 sulfur, I have to put a 5 here. Okay, then what should I do next? Balance oxygen. I have 8 on the left side, and I have put an 8 here to balance the oxygen. And carefully count hydrogen. On the right side, you have 16. On the left side, you already have 10. So you have to put just a 6 here. It will be all automatically balanced. That's why I said it's little similar, because hydrogen is available here. Right, that's done and dusted. And moving on to this one, manganese +7, SO2 +4 sulfur, and here manganese +2. In SO4 2 minus, sulfur is +6. Manganese from +7 to +2, difference is 5. Sulfur from +4 to +6, difference is 2. 2 manganese, you put a 2 here, settled. 5 sulfur, you put a 5 here, settled. Balance oxygen. How many oxygen do I have? Let's see. Here I have 18. All right. 8 plus 10, 18. Here I have 20 oxygen. 5 into 4 is 20. So I have to put a 2 here in order to balance oxygen atoms. Right. And the only way to balance hydrogen atoms, here we have 4 hydrogen atoms. We don't have any hydrogen atoms in the other species. Here we have only one H plus as a species. So we have 4 here. To balance it, we have to put a 4. Balanced. Right. Done. That's easy. And if you take this one, manganese +7, here it goes to +2. Iron from +2 goes to +3. Manganese, the difference is 5, +7 +2 difference is 5. You put that 5 into front of iron, settled. Iron +2 to +3 difference is 1. That 1 comes here. Manganese is 1, already balanced. 5 iron, so I have put a 5 here. And then let's balance oxygen. I have 4 oxygen atoms on the left side, so I have to put 4 water molecules, and 8 hydrogen atoms on the right side now, so I have put 8H plus. Done and dusted. Next one, manganese, permanganate from +7 to +2. Iodine from -1 to 0. Manganese from +7 to +2, the difference is 5. Iodine from -1 to 0, difference is 1. But the problem here is 5i minus, here we have I2. Here we have an odd number, here we have an even number. So you can't balance it. What should you do? This time you have to make 1:5, 2:10. With this 2, you will be balancing manganese. And with this 10, you will be balancing iodine. Right. And then we have 8 oxygen atoms. I have to put 8 water. And I have 16 H hydrogen atoms on the right side. Therefore, I have only H plus on the left side with hydrogen. I have put a 16 here. Right. So, yep, that is balanced. Done. And next, moving on to the next one. Manganese is at +7. Nitrite +3. You know, 2 minus. Manganese here is +2. Nitrate +5. Manganese from +7 to +2, difference is 5. Nitrite from +3 to +5, difference is 2. Using this 2, let's balance manganese. I have to put a 2 here. And using this 5, let's balance nitrate. 5. Done. Then I have to balance oxygen. Careful. On the left hand side, you have 8 plus 10, 18 oxygen. 8 plus 10, 18 oxygen. On the right side, you have only 15. 5 into 3. Therefore, I have to put a 3 here. I have to put a 3 here, and I have 6 H atoms on the right side. Therefore, I have to put 6H plus balanced. Okay, 6H plus balanced. And yes, I think that's correct. Yeah, give me a second. Yes, that's correct. Good. And this one now, it is similar to this question we did. One where chromate reacted with conc HCl. This is similar to that. Fine. It's similar to the one we discussed before, this one, where the dichromate ion reacting with concentrated HCl, here permanganate reacting with concentrated HCl. So both will be more or less same. Let's see. Here manganese, it's
now it's a paying.
And here
paying, it's Anuwa kapita gin bank with.
And chlorine is -1 in this one, and then chlorine goes to 0 in this one. All right. Manganese from +7 to +2. What's the difference? The difference is 5. So I'll put that 5 small like this. Right. And chlorine from -1 to 0, the difference is 1. Using this, okay, manganese, we have only 1 here. It's already balanced. Using this 5, I have to balance this chlorine. But there is a problem. With this 5, I can't balance this chlorine because we have odd number here. We have even number here. Therefore, what should I do? Instead of putting 5 and 1 here, I should put 2 and 10 here. How did 5 and 1 come? How did 5 and 1 come? +7 to +2, difference is 5. -1 to 0, difference is 1. So 1 and 5. But with that 5, I can't balance the chlorine. That means Cl2. Therefore, I should make it 2 and 10. I'll put 10 small because we will have to get rid of that. 2 manganese, so I have to put a 2 here. 10 chlorine. With this 10 chlorine, I have to balance Cl2. That means 5. All right, good. And then to balance oxygen, I have oxygen in MnO4-. I have oxygen in water. That's all. I have 8 oxygen here. To balance that, I will put 8 oxygen here. Right, done. 8 water actually. 16 hydrogen molecules are there on 16 hydrogen atoms are there on the right side, but I have only 10 here on the left side. So there is a contradiction. What do? We get rid of this, and then we make it 16, don't we? We make it 16 because if you leave it as 10, it doesn't tally. 16. Okay, and then count chlorine again. We have 16 chlorine, only 10 are balanced on the right side, so 6 remaining. You have to put 6 Cl minus. That is how you balance this reaction. 2, 16, 2, 5, 6, 8. The two reaction, this reaction and this one, they were a little exceptional cases. They were somewhat exceptional because we had to do we had to balance the equations using trial and error method. We put a number, it was wrong, we had to cancel it and put a new number. All right. Every reaction is not like that. Very rarely we will come across reactions like this. We have pretty much covered almost all the reactions here. So this is pretty much the set, but still you might come across maybe a few more different reactions, but the concept still remains the same. Okay, we have one more at the bottom. Yeah, this should not that be hard. In permanganate, manganese is +7. In oxalate, carbon is +3. From +7, it goes to +2. From +3, it goes to +4. Oh, carbon from +3 to +4. Manganese from +7 to +2, the difference is 5. So that 5 in front, it comes in front of oxalate. Oxalate from +3 to +4, the difference is 1, but there are 2 carbon atoms, so you put a 2 here. And then you put, to balance the manganese, you put a 2 here. To balance carbon, there are 10 carbon atoms here, you have to put a 10 here. All right. Then count oxygen now. 20 oxygen is balanced with this 20 oxygen. But here we have 8 oxygen with permanganate. That oxygen is not balanced. For that, we have put 8 for water in front of water, 8 in front of water. And we have 16H plus on the right side. To balance that, I have to put 16H plus on the left hand side. Right, 16H is on the right, balance that, you have to put 16H plus. Okay, right, that's it. The reaction is correct. That is how you balance it. That's not that hard. Yeah. All right. Well, next question. This one. This is pretty easy, not that hard. H2O2 minus 1 oxygen goes to minus 2 oxygen. Right? It is getting reduced. Whereas iodine from minus 1 gets oxidized to 0. In H2O2 oxygen from minus 1 to minus 2 difference is 1, but there are 2 oxygen atoms. Therefore, 2 should be included in front of I minus. And I minus from minus 1 to 0 difference is 1. That 1 goes in front of this. Okay, 2 iodine done. And how do you balance it? How do you balance the rest? Oxygen atoms. We have 2 here. I have to put a 2 here. And then check hydrogen atoms. I have 4 here. From this, I have 2. So you put a 2 here. 1, 2, 2, 1, 2. That's it. Pretty straightforward, that one. And here again, H2O2 minus 1, ion plus 2. Ion goes to plus 3, and H2O2 goes to minus 2. H2O2 from minus 1 to minus 2 difference is 1, but there are 2 oxygen atoms. Therefore, we have to put a 2 in front of ion. Ion from plus 2 to plus 3 difference is 1. That 1 goes in front of H2O2. Okay. What should I do? 2 oxygen atoms on the left hand side. I have to put a 2 to balance the oxygen atom. And don't forget ion. I have 2 ion, so I have to put 2 here. And finally, hydrogen. I have 4 on the right side, 2 here, put a 2 here. That's it. 1, 2, 2, 2, 2. Easy. Next one, permanganate, plus 7. Here it goes to plus 2. H2O2, minus 1. Here it goes to 0. Permanganate from plus 7 to plus 2, difference is 5. In H2O2, oxygen from minus 1 to 0, difference is 1, but there are 2 oxygen atoms, therefore I have to put a 2 here. 2 manganese, so I have to put a 2 here. And with this 5O2, this oxygen must be balanced, 5O2. All right. And then the remaining oxygen 8 should be balanced with water. And altogether, I have 16H on the right side. I have only 10 here. So I have to put a 6 here to balance it off. Right. And how about this one now? Chromate. I think we did this before, right? I think by mistakenly it is printed twice. Never mind. Dichromate from plus 6 goes to plus 3. H2O2 from minus 1 goes to 0. Careful, not minus 0, because dichromate is getting reduced. So H2O2 should get oxidized, not minus 2. Careful, huh? It's getting oxidized, so 0. Dichromate, people, plus 6 to plus 3, difference is 3, but there are 2 chromium atoms. Therefore, I have to put a 6 here. And in H2O2, I have minus 1 for oxygen. It goes from minus 1 to 0. Difference is 1, but I have 2 oxygen atoms. Therefore, I have to put a 2 here. What's the problem? It's not the simplest ratio. Therefore, you have to change it to 1:3. 2 chromium atoms here. You have to put a 2 here. What else? With this 3 O2, I have to balance O2 because H2O2 is getting oxidized to oxygen. Right, then how many oxygen atoms do I have in addition to that? I have 7 oxygen here, which is not balanced, so I put 7 water molecules. And hydrogen atoms, carefully count it. On the right hand side, I have 14. On the left hand side, I already have 6, so I have to put 8 here. Balanced, done. Okay, now the last one, there is a small issue there. You have to be really careful in that one. 2 species are getting oxidized. That's the interesting part. 2 species are getting oxidized. Now, if you look closely, we have copper 2 sulfur, copper 2, I mean Cu2S. Now, what is Cu2S? Cu2S is in fact, in that we have 2 copper plus ion and sulfide ion. If you write the IUPAC name, it's going to be copper 1 sulfide. That's the name of that. So we have copper plus here. Copper is at +1 oxidation state. Sulfur is -2. You have to be careful there. And copper from +1, here it has gone to +2. Let's use separate colors for each, then I think it will be clearer. Copper from +1 has gone to +2. And sulfur from -2 has gone to what? +6 in everything. It has +6. So I'll just put a plus 6 here. +6, +6, +6. Sulfur has gone to +6. So both copper and sulfur have got oxidized, whereas manganese from +7 as usual has gone to +2. So it has got reduced. Okay. Manganese from +7 to +2, difference is 5. We put that 5 here. All right. Now copper, careful. Copper from +1 to +2, difference is 1, but there are 2 copper, so 2 from copper. Sulfur from -2 to +6, -2 to +6, difference is 8. Difference is 8. Therefore, from copper we are getting 2, from sulfur we are getting 8. Overall, it should be 10 in front of KMN of 4. Hope you guys understood it. How is this 10? How is this 10? How did we get 10? We got from copper, it was 1 into 2. The difference is 1, but there are 2 copper. From +1 to +2, the difference is 1, but there are 2 copper ions here. Therefore, 1 into 2. And from sulfur, wait, I will write from copper. It's like this. If you take copper, what the change happening is it goes from +2 to +1 to +2. Difference is 1, but there are 2 copper atoms. Therefore, 2. From sulfur, if you take from -2, it has gone to +6, and there is only 1 sulfur atom. So from -2 to +6, what's the difference? It's 8. 8 into 1. Therefore, it's 8. So altogether 10, and that 10 must be put here. Okay. So 5:10. 5:10. We can simplify that, can't we? Because it's not the simplest of ratio. We can change it to 1:2. 1:2. So let's get rid of that. I will get rid of that with a very thin line, so that you will still have that 5 and 2, right? 5 and 10, right? So 5 becomes 1, and this 10 becomes 2. Okay. Now with this 2 is in green. I'll try to balance the ones I can balance. Now with this 2 potassium, I can put, it's already balanced, so I'll put a dot here. It's settled now. 2 manganese, so I have to put a 2 here. All right. Copper, now using this copper. Now we have copper in front of this. There is 1 copper, 2 are there. So I have to put a 2 here to balance copper. Right. 2 here to balance copper. Right. Fine. Great. Now that's it. And then what should we do next? We should check the sulfur count. We should check the sulfur count. So what's happening with sulfur count here? To check the sulfur count, we have 1 here. It can't be changed. And on the right side, we have 2, 4, 5. Okay, 2, 4, 5. 5 sulfur atoms are there on the right side. On the left side, only 1 is there. This is not 5. I have cancelled it out and made it 1. Only 1 is there. Therefore, I have to put a 4 in front of H2SO4 to balance sulfur. If I put a 4 in front of H2SO4, hydrogen must be balanced. I have 8 hydrogen here, and I have to put a 4 in front of water as well. All right, that's it. So that way, it will be balanced. Fine. Here we have another example which is similar to the previous one, right? So first of all, you have to analyze what we have in here. Now this is FeC2O4, where we have Fe2 plus and oxalate. When you say C2O4, you should understand it is C2O4 2-. Therefore, this has to be Fe2 plus to balance out the charges. So Fe2 plus and C2O4 2-. And in Fe2 plus, ion is +2, In C2O42 minus, carbon is +3. In oxalate, carbon is +3. So both these species are going to get oxidized because of KMnO4. And what has happened to iron? From +2, it has gone to +3. From +2, it has gone to +3. And what has happened to carbon or oxalate? From +3, it has gone to +4. So I have used red for the species which are getting oxidized. Let's use blue for the species which is getting reduced. That is permanganate +7, manganese goes to +2. From +7 to +2, what's the difference? 5. Okay. Iron from +2 to +3, 1. Carbon from +3 to +4, that is 1, but there are 2 carbon atoms. Therefore, 2. From iron, we will be getting 1. From carbon, we will be getting 2. Therefore, I have to put a 3 here. Hope you guys understood that. You will get a 3 here. You will get a 3 here. And how did that 3 come? A 3 came from iron. You get from +2, you go to +3. Therefore, it's 1. And from oxalate, what happened? In oxalate, from +3, you went to +4. So from that, you will be getting, change is 1, but there are 2 carbon atoms, therefore 2. So 1 + 2, that is this 3. But with that 3, now see, you will try to balance potassium. With 3 potassium, you can't balance this. And even with 5 iron, we have 5 iron, but here we have even number, F2, Fe2, K2. Therefore, this 5 and 3 must be changed. Changed to what? It must be changed to 10 and 6. Because with 5 and 3, you can't balance the reaction. Right. Great. So 10 and 3. So I'll change the numbers. Instead of 5, I have to put 10 here. Instead of 3, I have to put a 6 here. Right. Okay. Let's see what we can do with these numbers we have now. With 10 iron, with this 10, I am going to balance this iron. That means I should put 5 here. It's settled. And with this 20 carbon actually, I have to put a 20 here. Okay, 20 there. Good. And with the 6, what can I do? With the 6 potassium, so I have to put a 3 here. 6 manganese, so I have to put a 6 here. Good. And then let's continue further. What else should we do? We have to balance the sulfate ions. Now, people, sulfate ions. That's because we have sulfate in H2SO4 and we have sulfate here. Now, how many sulfate ions do I have here? I'll underline them. 15 here, 3 here, 6 here. All right. Altogether, hope you can understand. Altogether, we have from here 15, from here 3, from here 6, 15, 3, 6, 24 sulfate ions. Gosh, 24. That's a lot. To balance that, on the left-hand side, you have only H2SO4, which is going to provide sulfate. So I have to put 24 here. Okay. Right. Now look, check hydrogen. Yeah, 48 hydrogen. To balance that, definitely we'll have to put a 24 here. No other option. Okay. And this 24 oxygen is actually this 6 into 4. And everything is balanced. So the answer will be 10 is to 10, 6, 24. 5, 3, 6, 20, 24. And it's similar to the previous example we just discussed.